So after you remove common factors, you're then going to look for the special factor forms. And the special factor forms are pretty much just the reverse of what we did with the special product forms. Okay, so if I take a look at a couple of the special factor forms. Okay, we've already talked about, I believe, have we talked about the difference of squares? I think this might have been earlier, but the difference of squares factors into the sum and difference of the terms. So again, this is the exact reverse process of what we just did. I think we also talked before about something that fits the pattern of this perfect square trinomial. It can be factored into a binomial square. Okay, so if your first and last terms are both perfect squares, and the middle term is double the product of the bases that are being squared on your first and last term, then you can factor that into a binomial square. It's just the sum of the terms that are being squared. And so what that means is it would be something like this. And so if you had an expression that looked like this, what you could do is you could identify, are the first and last terms both perfect squares? Yeah, this is the quantity 2x squared, and this is the quantity 7 squared. If you take the product of these and double it, do you get this middle term? Yeah, so this is a binomial square. You're just going to take the two terms, 2x and 7, and then the sign of that middle term becomes the sign of whatever you put in between. All right, there are two new special factor forms for these higher level or higher order polynomials, and that is the sum and difference of cubes. And so if you have two perfect cubes being added or subtracted from each other, there is a special pattern for this, and the special pattern is you just take the two terms that are being cubed, so a and b, and you're just going to combine those. And then your second factor will be a trinomial, meaning three terms. The first term will be this first base squared. The last term will be the last base squared. And the middle term is going to be the opposite of their product. So a times b, the opposite is negative ab. And so that would be the pattern that you're looking at. Now, this pattern holds true whether you're taking sum or difference of cubes. Okay, the book and most books will present this as two different things. Okay. But the pattern is exactly the same. The words that I'm going to use don't change between these. So when I'm looking at this difference of cubes, I take my first factor is a binomial. It's just the two terms that are being cubed. Well, the first term is a, but the second term, the negative b, is being cubed. Because what is negative b cubed? Negative b cubed. So the negative sign is accounted for just by thinking in terms of that same rule. Just take your two terms that are being cubed and combine them. And then your second factor is the first term, a squared. The last term of the second factor is your last term, this negative b squared. Well, when you square a negative, it still becomes a positive. So plus b squared. And then if you take the product of these terms and then change the sign, plus the opposite of the product. So a times a negative b is negative ab. Change the sign, and you get your second rule. But again, sum and difference of cubes, if you can think of it the way that I worded them, it's the same rule. Doesn't matter which way you're talking about. And so where this special factor form or what it might look like is if I gave you something like this. Okay, what you could do here is you look to see, are there any perfect cubes, or are these both perfect cubes? Well, what quantity can you cube to get 64? And so think about, here's your perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed, 64, 5 cubed, 125, and 6 cubed, 216, 10 cubed, 1,000. So those are basically the perfect cubes that you should be able to recognize just with a quick little mental calculation. And so the base that's being cubed to get 64, x cubed is 4 and x. And for the 125, you're cubing what base? 5. And so when you factor this, you're going to have a binomial and a trinomial. The binomial is just the sum of those terms, so 4x and 5. The trinomial, you're going to square the first term, so square the 4, square the x. Your last term is going to be the square of that last term, 5 squared, which is 25. And then your middle term is just going to be the product of these and then change the sign. So what's 4x times 5? 20x. Change the sign, you get a negative 20x. Okay? And so that becomes your set of factors. Okay. One more demonstration just with the difference of cubes. So here, let's say we have 27x cubed minus 8. Okay. So when you look at this problem, again, what you do is you look to see, are these both perfect cubes? 27x cubed is what quantity cubed? Remember, it's 3x. And then negative 8 cubed. Again, because you're dealing with an odd power, the negative sign carries with it. So what base can you cube to get a negative 8? Notice, again, the negative is part of what I consider the base being cubed. Now, when you look at this special product rule, or the special factor rule, the first binomial factor is just the combination of these two bases. So 3x and a negative 2. This sign takes care of itself. And then you're going to take the first base and square it. So 3 squared, x squared. Your last term is going to be the second base squared. So negative 2 squared is still a plus 4. And then if you take the product of these two bases and change the sign, that's your middle term. 3x minus 2x is negative 6x. Change the sign. And so again, the same rule applies. You don't need to think of it as two separate rules. The which one? This second factor?
Yeah.
And so my first factor, again, is just the combination of these terms. And then the second factor, what you're going to do is take the first term and square it. So negative, or 3x, quantity squared, gives you 9x squared. Your last term is going to be the last base squared. So negative 2 squared is positive 4. And then when you take the product of these two bases and change the sign, that's your middle term. So 3x times a negative 2 is negative 6x. Change the sign to get your middle term. That's what the pattern, the pattern is for that is you change, it's minus the product AB. All right, once again, you have your calculators to verify all of this. The factor key is under the algebra tab, F2. So if we were to factor this expression, let's say 64x cubed plus 125, close it off and hit enter, it confirms that we got the right expression.